Introduction. Differentiation is a fundamental subject in calculus that deals with determining the derivative of a function, which effectively measures how a function's output value varies as its input value changes. This concept is fundamental to mathematics and has several applications within the field itself. Here, we look at some of the most common uses of differentiation in mathematics.
Okay, for the solution of part B, equation 1, A1 Roman, is to find 1 in term of x. So, the rectangle and a triangle is shown at figure 1 below, is shown like this. So, to find 1 in term of x, we must add all the parameter, x plus 1 plus x plus 3x and plus 5x equal to 100 cm that given at the equations. So, simplify the x, 2x plus 3x plus 5x plus y equal to 100 cm, and then 10x plus y equal to 100 cm. And then make sure the y is single at the left. So y equal to 100 minus 10x. So the answer is y equal to 100 minus 10x. For the equation 2 Roman, and that shown that there is a triangle and rectangle, and then there is the formula of triangle and rectangle. So area is 1 over 2 multiply y multiply 3x, and then plus the rectangle x y, and then it easily simplify the equations 3xy over 2 and plus xy, and then from the equation 1 Roman is y equal to 100 minus 10x, and then easily substitute in the equations. So 3xy plus 100 minus 10x over 2 and x multiply 100 minus 10x. So simplify the equation so that we get 300x minus 13x squared over 2 plus 100x minus 10x squared. And then, so 300x divided by 2 is 115x minus negative 13 over 2 is 15x squared plus 100x minus 10x squared. And then easily add 115 plus 100x, so that we get 215x over 2 minus 25x squared over 2. And then for the final answer is 125x minus 25 over 2x
For
squared.
the third Roman question, the question orders to determine the value of x and y so that the total area, which is a, is maximum. So the equation for a is actually given in the second Roman question, which is a is equal to 125x minus 25 over 2x squared. So when a is maximum, we need to convert a into dE over dx. So therefore, we need to derive this equation. So x we find 1. So this one we need to move it to the front. Therefore, okay, we write it like this, and then copy back 125, and then the power of x we need to minus with 1. Therefore, we got x power of 1, and then we minus this power. Like the previous, we move the power in front. So write 2, and then copy back 25 over 2, and the power will minus with 1. Therefore, we got x with power of 1. So it is optional to write 1 or not. Okay, therefore, we calculate this equation. So anything that multiplied with 1, we will get the same answer. And anything that have a power of 0 is 1. Therefore, we got 125. And then for this part, we can actually simplify it, okay, into 25x. Therefore, we got our dE of dx. So to find dx, we can assume that dE over dx is equal to 0. Therefore, 125 minus 25x is equal to 0. So we need to make x alone. So therefore, we move 125 first. Then we got 0 minus 125. Okay. And then 0 minus 125 is negative 125. And then we move negative 25 below since it is multiplied. So for this part, we need to divide it to negative 25x. So we got 5. So our x is 5. Okay. So to search y, I use theorem Pythagoras. Is 2x, hypotenuse is 5x, and this part is y. So we use this equation. B square is equal to c square minus a square. So y square is equal to 5x square minus 3x square. Therefore, most students will make a mistake here since they will only square the number. But the right thing to do is to square both in the bracket. So we got 5 square x square minus 3 square x square. Then we got 25x square minus 9x square. And then we need to make y alone. So we need to move the power to the other side. Therefore we got y is equal to square root of 25x square minus 9x square. So this is the equation for y. So since we got that x is equal to 5, so we can substitute x into this equation. So we will get x is equal to 25 5 square minus 9 5 square. So we will get 25 times 25 is 625, and then 9 times 25 is 400. I'm sorry, it's actually 9 times 25 is 225. So then we got square root of 400, and square root of 400 is 20. Therefore our y is 20. So for the fourth Roman, the question one is to find the maximum error. So the equation for error is a is equal to 125x minus 25 over 2 x square. So since we got that from the previous question, we got that x is equal to 5. Therefore we just substitute the x into the equation, and then we got 125 in bracket 5, 25 over 2 in bracket 5 square. Then calculate. Then we got 312.5 unit square since it is area.
The first question is to show that y is equal to half times 75 over x minus x. Based on the question, we have been given the total surface of rectangular area is equal to 150 meter square, and it has square base, mean x times 2x, and base is equal to the top here. And other than base and top, we have x times y for side. And the area formula for rectangular is length times width. So 2 times x square plus 4 times xy, and we can substitute area to 150 equal to 2x square plus 4xy. And then since we want to find y, we bring 2x square to the left, and we got 150 minus 2x square is equal to 4xy. And then we bring 4x and left y at the right, and then we can split the equation. 2x square 4x is equal to y, and we can simplify the equation and get 75 over 2x and x squared over 2 minus is equal to y. And we can bring out 1 over 2 multiplied by 75 over x minus x is equal to y. Have answered the question.
Okay, so find the maximum volume of the container. So V we know length multiply with multiply 8 and substitute Y. That's equal 1 over 2, 75 over x minus x into volume formula. So V equal to x square multiply 1 over 2, 75 over x minus x. So that we get 75 over x minus x over 1 equal to 75 minus x square over 2x. And then V equal to x square multiply 75 minus x square over 2x. And then V equal to x 75 minus x square over 2. And then v for the last is 75 minus x cubed over 2. Then for the first derivative is we get v equal to 75x minus x cubed over 2. And then we dx the equations, so that's we got 75 minus x squared over 2. And then we proceed for the second derivative. And then so let dv over dx equal to 0. And then for the final value of x, we equal to the equation to 0, and then 75 minus 3x squared over 2. And then we got 0 equal to 75 minus 3x squared. And then we make it the 3x squared to the left and 75 to the right. And then we got x squared over equal to 25, and then we need to x and then make the x is single, and we got the 5.
To find v max, we need to sub x is equal to 5 into v is equal to 75 minus x cubed over 2. So v max is equal to 75 times 5 minus 5 cubed over 2. And we have 250 over 2. And simplify, we have v max equal to 125 meter cube for the max volume.
So, in conclusion, differentiation allows us to understand and manage changes and variations within various contexts, from academic fields to practical business applications. Its application helps in optimizing processes, predicting outcomes, and making informed decisions. So, differentiations, whether in mathematics or business, offer significant benefits in real life applications. So, for the first benefit of differentiation is in mathematics and physics, since we can use differentiation for optimization. Differentiation helps find maximum and minimum values in various functions, aiding in optimization problems. So for motion analysis, for example in physics, it aids in understanding motion by relating velocity and acceleration to displacement. So for the next benefit of differentiation in real life is business and economics, since we can calculate cost and revenue analysis by differentiation. Other than that is it helps businesses determine marginal costs and revenues, and optimizing profit margins. So next is demand and supply. Since differentiation can help us to analyze the changes in supply and demand to adjust pricing and production strategies. So for the third benefit is in engineering, since differentiation contribute in design optimization. Okay, for example, engineers use differentiation to optimize design parameters for better performance and efficiency. So in control system, differentiation helps in the design of control systems by analyzing dynamic. So differentiation also contribute in medicine and biology for growth rates. It is because differentiation helps in better understanding of the growth rate of cells or populations to develop better treatment plans or conservation strategies. Other than that is differentiation can helps us to determine the right drug dosage by optimizing drug dosages over time to maintain therapeutic levels in patients. So in summary, differentiations equips individuals and organizations with powerful tools to analyze, predict, and optimize various aspects of their respective fields, ultimately leading to more effective and efficient outcomes.